Okay, now in this video we'll be noting some basic things in binomial expansion. So given any binomial expression and you have this to be the standard form of its expansion, where we have a sum from 0 to n, okay, that is we are selecting r from n from 0 to n of n combination r, a to power n minus r and x to power r, okay, where a is the first term and x is the second term in the binomial expression. Okay, and we take our n and r from the set of integers, that is to say they are whole numbers starting from 0 to the right. Great. Now notice first that as the power of a decreases, okay, in the expansion, look at this. As the power of a decreases, then the power of x increases. Now let's be given a particular example where you say, okay, for example here we have a plus x, let's call n 3. Okay, let's raise it to power 3. Then we will see that we have, in the first case, okay, we have 3c0 and that is equal to 1. Okay, so we have that to be 1 times a raised to power n minus r. So we have that to be 3x raised to power r. We have that to be 0. Okay, that is the starting. R is 0. So the next term we will have plus, now we have nc, the next term r is 1. And that is just 3. Okay, a to the n minus 1. 3 minus 1, that is 2. X to the 1. That is just x. Plus, the next we consider is nc2, and nc2 is just 3. Okay, we have nc2, and that is 3. 3 is here, the n is 3. That is 3 factorial divided by 3 minus 2 factorial, 2 factorial. So we have 3 factorial, 3 minus 2 is just 1, okay, so that's 1 factorial. So we have 3 factorial divided by 2 factorial, and 3 factorial could be written as 3 times 2 factorial, right, divided by 2 factorial, and we see that you can cancel this right here and we are left with just 3. So that's it, alright. So when I'm saying 3c1, you just evaluate it like this using the general formula for binomial combinations. Okay, so we move. Now we have here to be 3. Okay, and the next thing we consider is a to the n minus 2. 3 minus 2, that is a to the first degree, x to the second degree, plus the next one we consider is ncn. At this point r gets from 2 to 3, that is in the fourth term. So 3c3 is just 1. Okay, so we have it to be 1 times a to the 0, you know. At this point r is something as n, that is 0, it's gone, or it gets to 1, and x to the third degree. Okay, so at this point we observe that as a was 3, x was 0, in the second term, forget about the coefficients now, let's just focus on the powers. In the second term, x reduces by 1 to 2. A reduces by 1 to 2, x increases by 1 to the power 1 here. And in the third term, x reduces again from 2 to 1, and a reduces again from 2 to 1, and x increases from 1 to 2. And here, a reduces from 1 to 0, and x increases. So, for the binomial expansion, okay, the powers of x, or the power of the term in the second term increases while this one reduces. Okay, well, one may still choose to take it the other way, that he starts with this one, he starts with the last term first, such that this one is now reducing and this one is now increasing. But whichever way, you should know that the power of one must be reducing while the other increase. And when that happens, you should take note of this second rule, which we states that the power of a and x in each term in the series always adds up to n. So you want to increase or you want to reduce, make sure that the sum of the powers in each of the term in the series, that is this third term, the first term, or the second term, or the third term, or the fourth term, whatever term, make sure that the powers of the two terms here in this binomial expression is equal to 0. The sum of the powers is equal to 0. For example, here we have 3 plus 0, which is just 3, 2 plus 1, which is just, okay, and so on. So it must not be less than n. If it is less than n, then there's an error somewhere. If it's greater than n, then there's an error somewhere, so you have to recheck your work. It shouldn't be greater than or less than n, rather it should be equal to n. That is the sum of powers of the two terms in it there. Okay, another thing we consider is that for any term, we can choose, let's say in this binomial expansion that consists of 4 terms, 1, 2, 3, 4. Any term in it, let's say the second term, then r, the value of r will be m minus 2. So if you are considering the second term, okay, then the value of r should be 2. That is the cardinal now. When we're considering the ordinal, the value of r should be the 2 or the cardinal minus 1. It's very constant. So we were considering the first term. The ordinality is first, but the cardinality there is 1. Okay, our r was just 1 minus 1, which is 0. That is the first term. Now in the second case, our r was 2. That gave, in the second case where we have the second term, okay, r is now 2 minus 1. So in the second term here, so that is how we get your r. So you take note that as this first power reduces, this other one increases, or better still, that the sum of the terms in the series should always be the power there, that is n. And finally, that to get your value of r, you should take note that r is the term you are considering, the cardinality there, minus 1. So with this third notice, we can be asked to find coefficient of the sixth term. So you know that the sixth term, the value of r there is automatically just 5. In the seventh term, the value of r there is just, okay. So with that, you can just get on with it, alright? So such examples we'll be doing in our next video. But for now, I hope this is helpful enough, and please subscribe to this channel.